So we're going to do an intro to Kentik and a little bit of an update on what's new for people that have been following Kentik. Dig into some of the things that we've done working with service provider, which is largely about people that are communication service providers, cloud providers, people that provide access to others, but also a lot of modern enterprise or think of themselves as service providers and actually do have customers internally. Do a little bit of a tech talk about how we take traffic and augment it with what it actually means to the business. As people are looking at really modernizing their monitoring and observability stacks, it's an interesting thing, even for people that are thinking about DIY and how they bring things in. And then talk about cloud infrastructure, different ways of looking at it, bringing it into the context of everything that you already, all the assets that people already have, and a little bit about cloud native, which has been pretty awesome evolution for us because now there's a place you can go to say, what is this application? What is this service? Where is it running? But also you've got some parts of the organization running ahead of IT. So how do you bring that together? And then a little bit about what's ahead. For those that remember the last time, we have a roadmap. We also have a negative roadmap that we use to keep us focused on what we're doing. So a little bit about Kentik. We are a almost 5-year-old company based in San Francisco. My background is I started an ISP in Philadelphia in 1992 because there was no way to buy internet access as a consumer in Philadelphia at the time. Grew that. I learned about BGP. Anyone remember Boardwatch magazine for BBS? Wrote BGP articles for that and talked about that. Worked at Akamai for 10 years, ran the network group there. And after I left, fell into how do people actually understand and run the network infrastructure. We have a couple hundred customers, about half of them are enterprise and half of them are service providers. Focused US as a company, but we have we have customers in about 26 countries. That's a little bit about who we are. So our focus, even from when we started in 2014, I had been selling network sensors before that for people that were trying to understand forensics of performance and security, and really just started understanding that the solutions that were commercially available, most of them appliance-based, were not being well received by people that were trying to evolve the network. Even back then, people were thinking about how do we work more like web companies? How do we specify and automate and run? And the biggest gap and where we started was around the internet side. Really understanding the internet centralities, people using CDNs and their customers and Twilio and Google Maps and all those things. And also it was clear even then, and it's become more clear that things are changing, and you guys hear about that a ton. And the way Kentik started is actually with the thesis that we needed to be able to observe everything, keep it, have machines do the work of trolling through it, calling out interesting insights, but that it was always going to remain important for humans to be able to be part of the loop and understand, debug, tune, integrate. The network stack has often been a separate thing, only used by the network architecture, infrastructure, operations, and the way we're seeing is that people really want to integrate that. And a lot of the solutions, if you look at the open source solutions, Silk from Carnegie Mellon, NFDump, PM Account, doing that on top of Elk, like a lot of the core network traffic solutions, which is where we focus, NetFlow, SFlow, IPFix, host monitoring, flow logs, what's actually happening on the network. Those open source solutions run on one machine. So even back 2011, 2012, 2013, running diverse, complex, high traffic networks has been difficult with those solutions. And so we also have always focused on not just network operations and not just the security side. We're a little bit more on the operation side. DDoS detection and tying to integration with mitigation has been a big use case for us because a lot of our customers focus on the internet side. But we've always viewed that as an availability problem, not a security problem. Right? If I kidnap you, then it may be difficult for your business to run, and it might make it easier for me to pick your pocket. But kidnapping you itself is an availability problem. Stopping your internet access is itself that way. But the more things go towards provision specified automated infrastructure, I don't know for the folks in enterprise, but if you have a data center that really should only be running things that are provisioned from orchestration, anything that isn't tagged that way is by definition either something I won't use rogue in the scary thing, but something that's outside of what your policies and provisioning is, or something that's a security issue. So the better we make things from a automation and operations perspective, the more the security side comes in, and that's what we're seeing in our world. The people that we're dealing with, the network has been an increasingly important part of making things go. Now, we work primarily with infrastructure operations. There's certainly a lot of people who think that network is magic. It's API, and it's all software, and the complexity has gone away. We have customers that are running their own infrastructure. They're using CDNs, they're using Google, they're using Amazon. When they describe for us what their topology looks like between peering and interconnections and cloud connects and using the internet, it's gotten even more complex. So how do we help in that world and help support the people that think the network is magic, but actually make it work? So our approach is really more like, if you look in the cloud native world, observability. Let's take everything, let's take as much data as we can get. We provide a software as a service offering, so it's a big data platform that we run, people can log into, the data flows in, we tie into the automation systems, and people also use us via the API. And I promise you we'll get to the demo before long, so you can actually see the pretty Sankey diagrams and really even how we use the UI as an API navigator to allow people to tie things together. And it's, as I said, the goal is people to be able can get the data in. We enrich it with what that data means, and the tech talk is really about how do you build hundreds of routing tables of application, service, user, revenue, geo, yes, BGP. So when you take traffic data in, you can annotate it so you're not just staring at IP addresses and ports. And then I think, and we've demonstrated, there's a lot you can do with AI and machine learning and finding things. But at the same time, you need all the data to be accessible for humans to go look at things. So what we do is we take data from different sources, and we are traffic-based. So while we do take BGP routing data, we take SNMP data, and we're actually building a streaming telemetry and more flexible generic metrics platform. It all starts with traffic went somewhere to somewhere. Now that could be SFlow, NetFlow, IPFix, or it could be Istio logs, Fastly CDN logs, Nginx logs. Those might not have TCP flags, but they may have application performance and retransmits and network latency, which actually are what you need to stitch things together to see impact across the stack. We'll talk a little bit about the enrichment. That's really API based, or for BGP, we just take BGP peering. We have some things we include like geo and threat feeds, and then that gets augmented. And then the data goes into a streaming system which does anomaly detection and a column store database that makes it all available. So we actually are storing for some customers trillions of data points. And I'll talk a little bit about how we run this, because we're old server huggers and router huggers ourselves and run a private cloud to support all this. Most of our customers, we have a couple hundred customers, most of them are on our infrastructure, our cloud. But we have about a dozen customers that we run this either in service providers, more on-prem. They want this stack. They give us a machine that can, with Ubuntu, and we push button, pixie boot the whole thing. Or single tenant enterprise tends to still demand their data be single tenanted, but doesn't really necessarily want to run it. And not going to spend a whole bunch of time on this, but the big use cases are around performance, congestion, making sure that things are running smoothly on the network, security, forensics, DDoS detection, which a lot of our customers view as security, and it mixes between that and the operations. In the service provider space, it's also about sales prospecting. We actually have salespeople that log into Kentik to look at traffic flowing across the network and understand cost. Which in the enterprise is sort of cost of a group or application, and also application operations that are trying to solve the problem of where is the infrastructure issue. If you look at the APM tools, whether they're, I'd say the first new wave of AppD and New Relic, or even Datadog that's getting into that space, what they call infrastructure metrics is server SNMP. It's server metrics, basically, but they're still missing that. So how do we join that bridge? I think the network observability layer needs to understand the application context and be able to say there is a network problem here or there, but also link over to the application side, and the application side needs to have some network context, probably more than it does today. The groups that use us, it's the architect, planning, operations, NOC, the SOC. On the business side, that's more in the service provider space. Single sign-on, everyone can log in. We have enterprise customers with hundreds of users logging in to Kentik. So where we fit in the stack is up at the network layer, the network infrastructure layer. And if I look at our customers who are on the more modern infrastructure side, the people that are SaaS companies, web companies, even the modern enterprise side of the enterprise, the people that run what they call often the production network, not the corporate network with Wi-Fi and desktop, but the things that support the applications that make the business go talking to users. We typically see on the metric side, Prometheus doesn't really have a company around it, but people using Influx for DIY, Datadog a lot, more than VMware, which was Wavefront. We see Elastic a ton. How many people here use Elastic in their org? No? Splunk? Yes? Okay. So we see Elastic a lot just because it's a lot cheaper. And there's also a lot of plugins. And happy to talk about, at some point, if we have time at the end, what we see about some of this stuff. Because I think these have been too standalone, and part of our roadmap is customer-driven. How do we integrate the best? Distributed tracing, which is a modern way of doing application development, where you actually have transaction IDs. And again, we think about how do we get that down to the infrastructure layer on the APM side, and then testing. A lot of our customers have Dynatrace's Keynote. They have Catchpoint. Even more of them have Thousand Eyes, which takes a synthetic approach, whereas we're trying to look at the actual traffic. And again, I think that's an area where there could be more integration than there is today. So we're behind, and I apologize as a vendor for being part of that, but I think it's exciting. It is like being an ISP in the 90s. There's a lot to do, and then the infrastructure is changing out underneath. So our customers, we have CDNs that deliver the content. We have people that build the network like Tata and Telstra and Cogent and GTT. Where they're actually, again, using it on the business side. And then we have people that are digital enterprise, like Cisco, Neustar, people that run services for DNS and other things on top of the internet, e-commerce companies, people like that. So we generally start with the internet-focused side and then move to the data center and WAN. That's just typically how we start. Because a lot of these folks, as they go talking to each other about peering in transit, they need data. They're showing Kentik to people, and it spreads sort of that way. And so I'm a little concerned because there have been no pointed questions so far. I know Ethan's usually good for one or two, but so happy to talk about how we run. And they don't. In theory, I have access to the infrastructure, but they don't actually let me do anything other than the CEO cab, which does not have anything production. Before Jim, who you'll hear from, set up the modern lab, it was some old Usenet stuff on a SOUP 723BXL Catalyst that's still the router. But the way we run is everything that we're running, all our systems, very data heavy. This is a problem which I haven't tuned into the storage days, but the container persistent storage high performance is something which we haven't seen a great solution for. So we Pixie boot machines. Our storage nodes are running ZFS with our own column store on top, and then everything is distributed in containers. We have our own orchestration system today, not Kubernetes. That is a combo. It's a hybrid of it's all the same OS image across, and then of deciding what runs where with persistence, because SAN is the wrong architecture for our big data, and then the object storage is too slow. In cloud, when we take VPC flow logs, we proxy that and have infrastructure that scales in AWS and Google. But otherwise, for us, because we have a much more constant load, it's just cheaper to run our own infrastructure. And so we do in Equinix. We're all Juniper stack today. and VMX on the lab side.
In theory, as a customer, I don't need to
No,
care about
this is all because you're nerds, and I thought you might be interested.
This is just how you're
No,
doing the
this is all. So this conversation comes up when people say, "Can you run on our VNX in our VMware stack?" And we just say that's not the right architecture for storing, hundreds of terabytes or petabytes of data. But this has nothing to do with the end customer. It's just we run in this ecosystem, which helps us live the world of the customer. And then I wrote the first version in C. They rewrote it in Go to keep me away from the code. But all the hipster dudes all the hipster programmers like Go and now Rust. And it's traffic. The traffic we take is about half unencrypted. And that is an interesting security conversation because people say, oh, you're getting unencrypted traffic, but it's the headers that are going over the internet often anyway. But we have an encrypting proxy and people also cross-connect to us. So,
what's the use case for Rust? I could be wrong here. I think of it as a math-heavy language.
Rust is a language that makes you think enough about what your typing is that you can be without garbage collection, but do very high-speed things. So we actually use Rust. We just did a blog post, I think that'll be out, for our packet, basically packet and PCAP to flow generator instead of Go, because by not having garbage collection, you can deal with tens of millions of packets per second deterministically. We looked at it. We work with nprobe and we work with lots of different host sensors, but we needed something higher performance. So it lets you be faster deterministically than Go. So you see Go doing control plane stuff a lot, but not forwarding plane or not collection plane. So that's sort of where we live. And then C, Go is for lazy C programmers and smart Java programmers. So anyway, I'm old. You can. I don't think I'll offend too many people. And my problem in the automation space is just as an oldster is I don't think white space should be syntax. So Python constantly annoys me, and I like Perl, but the libraries are on Python, so that's what we do. But again, that's not my job primarily. What's new? So again, just as a recap, we're a network analytics company focusing across the infrastructure, but generally starting with the more modernized parts from the internet to cloud and data center, and then back into the WAN and some of the more traditional environments. We're about almost 5 years old and have been growing. And the big waves of things we've been doing are how do we go beyond just being the badass NetFlow tool that lets you slice and dice however you want, to bringing in the meaning of what that means, to what the traffic means, and then helping people make business use of it. So the functionality since about a year ago when we presented has been on taking traffic sources from cloud, and we'll talk about this because flow logs are interesting. They started from the security perspective, and on the Google side, they're actually really good. Every 5 seconds with latency data from their controller, from the SDN controller. On the Amazon side, the flow logs are still 10-minute delayed aggregates, more from the firewall side, but they're there. And this is a trend that we've been seeing is until you show people value, it can be hard for the infrastructure operations team to get an image, a sensor, a probe, an agent on the fleet of virtual servers that are being deployed. So flow logs have been very important as a way to get in there. And then also CDNs and other things that are part of the distributed architecture that see the traffic. And then also some of the metadata around that. And then on the automation side, we've seen, OpsGenie has come up, and a lot of PagerDuty users are moving there. A lot of routing layer flow spec integrations, especially around the DDoS side. But ServiceNow has been huge. And one of the big questions we get, which goes back to when I talk to CIOs, is all this stuff, enterprise automation, how? Like what workflows, how do I get data, how do I get an insight, how do I get all the context, how do I enable it? And so that's a big area that we work on is what kind of integrations can we do there. And on the service provider side, it's about driving the business. The budgets come from helping to operate, and you need to move beyond IP. For people, anyone know for the average US ISP, what percentage of Sunday night traffic is Netflix?
40 something?
I think more than 50.
Yeah, it's more than 50 and can vary. we have some customers, and Jim will show you a little bit in a demo. We've seen networks where 95% of the traffic doesn't come from necessarily specific ASs, but is from CDNs, content providers, overlay networks on the internet at times, right, at the peak viewing time, which is pretty amazing considering the internet still couldn't handle all the video traffic that goes over cable and television.
And 4K is just starting to become a thing.
Yeah, I mean, I describe Netflix as not the wave, but it's sort of the swell in the ocean in the distance saying, hey, we better figure scaling out because the stuff is going to be bigger.
So Avi, considering these different data sources and how you can munch them, and you're seeing data sources from all across the internet in some pretty significant ways, are you aggregating that data in a way that multiple of your customers benefit from it?
Not today. That is, I think I actually forgot to put that in the roadmap slide. We have to be very careful. So yes, we actually do for specific internet-wide security events, wind up looking at it. We're actively talking with customers about what's the way to do that, but it has to balance privacy, which, as I'm sure you know, is an even bigger thing, especially since a lot of the world thinks IP address is PII, right? But at the same time, you need to go down to maybe not the 128, but 64 or the 32 in the IPv4 space to be able to operate your infrastructure. But about half our customers, we do have the rights to do aggregates. And so what's interesting is we're starting to get from CDN, from cloud logs, enough performance data, not just the traffic movement, on top of the attack data that we already have. So we're thinking about how do we put that into the system, not just from content marketing, attacks and trends, and I don't know how many reports about everything you've downloaded in the last year, but how do we put it into the product but protect privacy? Where we're likely to start, and this is a little bit complex because our back end is designed so there is no God account, and there can't be, but is how do customers want to share data. People that work with each other that want to share data, so we're thinking about that. And then people want to know which clouds suck and which are better and all that stuff too, so we look at that. We're just about done on this side, but on the behind the scenes, there's been some work, which if we have time, we'll talk about in the tech talk, which is how do you actually deal with the speed of orchestration, right? So we have service providers that have millions of users logged in that want that user ID tagged to the flow, but people are turning things on and off, and sometimes, generally not only for sub-second, but today definitely for sub-hour. And if you look across a modern enterprise, there could be hundreds of thousands of those things turning on. And how do you deal with that at scale, which we'll talk about a little bit more, the tech detail. And then just the enrichment. How do you tie that to all the orchestration systems? And in the ideal world, which I don't know if we'll ever be in, I think, but it might get here before IPv6 turns off IPv4, I don't know. In the ideal world, everything would be described and orchestrated, and you have CMDBs and all that, and then everything else you just turn off. That's not in the next 5 years, I think, but we're seeing entire infrastructure where there's an actual data center, or at least a logical data center, where everything in it should be known. And I think that's big progress and very different than a couple years ago, and curious what other people are saying. And we'll show on the UI side, it's really about making it so you don't have to hold the network in your head, and different users, people from the infrastructure layer, can get value of understanding the infrastructure. So we have a few slides on service provider and then the demo, but I can take any other questions before we switch sections about what we're doing, why, things like that.
The tagging on AWS and NSX, how do you do the tagging?
So with AWS, it's interesting. With Google, they actually put the VPC name, source desk VPC, source desk project, source desk zone in the flow record in VPC flow logs, which is actually an awesome scam because they charge you per gigabyte. So enumerating that, or not enumerating it, but putting it in ASCII in the flow log makes them bigger. And in AWS, you don't get that. You get a firewall log, but it doesn't have the context. It doesn't know what zone, VPC, project, or any of the server tags. So we use the API that they have. We build the table, again, you could think of it like a routing table, dynamically based on what's being provisioned. And when the flow log comes in, then we add that to it. And then same thing with NSX or Contrail. There's context about the user set. It's domain specific. Each system has its own about what do you think this is, and then we can import that tag. And then, as Jim will show you, the same as IP address. You can say, show me from this tag to that tag, filter by that, which is a lot better way of doing things than looking up IP addresses and all that.